Divya sir, if you can hear me, the speaker is asking if he can join. So can we ask him to join now, or should we wait for some more time? Hello, sir. Good afternoon, sir.
So good afternoon. Am I audible? So am I audible? Okay, thank you.
I cannot hear you properly. Anyone, please respond if you can hear Dr. Sudheer Kumar Battula, sir.
Yes,
He
sir,
has
I
joined, but
can hear you.
whether we can hear him or not, please respond in the chat box at least if you can hear.
So someone has responded me that I can hear them.
Oh, so actually, I think I cannot hear his voice properly. Maybe some issue in my end.
But I can hear you, sir. Am I audible? Yeah, okay. Thank you. Yeah.
Okay, sir. Okay, sir. I'm joining from my phone if it is possible. Hello, sir. Am I audible now?
Yes, sir, you are audible.
Okay. So, Divya sir, shall we start then? Okay. Good afternoon. I'm Rangavala Pradhan. I'm an assistant professor in the Department of Computer Science and Engineering at ITER SOA University. I would like to welcome you all to this fourth webinar in the SOA weekly webinar series. That is SOAWAL-CSE 2. This is the second edition of this SOAWAL-CSE webinar series. So before moving forward in the webinar, first let me introduce our university to all the participants by playing a short video. So please do pay the attention so that we can know about our university, that is Shiksha Anusandhan University. I hope this video is visible to everyone. Sir? So that was a short overview of our SOA University. Now coming back to the webinar, this SOA weekly webinar series is a great opportunity for all of us to learn new concepts, technologies, new research directions every week, to listen to various experts and share their research perspectives. So in this regard, we have with us today our speaker for the day, Dr. Sudheer Kumar Battula, sir. Welcome, sir. Welcome to the webinar.
Thank you, sir.
So, to briefly introduce our speaker, Dr. Battula is currently working as an assistant professor in the Department of Computer Science and Engineering at SRM University, Andhra Pradesh. Dr. Battula is a researcher in the Information and Communication Technology and Computer Science and Engineering departments with outstanding research records. He received a PhD degree in Information and Communication Technology from the University of Tasmania, Australia. He received his Master's of Technology degree in Software Engineering in 2012. He was awarded Tasmania Graduate Research Scholarship (TZRS) for supporting his PhD studies. He joined the Faculty of Computer Science and Engineering at SRM University, Andhra Pradesh, as an assistant professor in 2021. His research interests include fog computing, blockchain, distributed file systems, cloud computing, IoT, and big data, all are very trending topics. Many of his research papers are published in top-ranking international journals such as IEEE, SCM, Springers, Elsevier, Taylor and Francis, Wiley, and NDPI. He has more than 22 Web of Science indexed articles. One of his articles is also recognized as the top cited article in the year 2020-21 by Wiley. Beyond this, he has established many research collaborations with several leading universities in Australia, Austria, Canada, UK, India, and New Zealand. He worked as a reviewer for many international top-ranking journals in the field of ICT. He has 9 years of teaching and research experience in ICT and computer science and engineering fields such as distributed computing, distributed file systems, blockchain. He has a sound experience of coding in different programming languages such as Java, .NET, C, and Python. He is Microsoft certified in virtualization, EMC2 certified in cloud infrastructure and services, and Oracle and AWS certified in Cloud Infrastructure Foundation and Associate, and he is also a Oracle certified Java programmer. So, with such a rich bio, we all must be eager to listen to our speaker. So without any further ado, I would like to ask Dr. Sudheer Kumar Battula sir to take over and present his talk on today's webinar topic, which is service-oriented computing. Sir, if you can share the screen now.
Yes. So thank you for the introduction, sir. I'm sharing the screen now. Are you able to see my screen?
Yes, sir. Yes, your screen is visible.
Okay. So good evening, one and all. So today I'm going to talk about the service-oriented computing. So I'm seeing this service-oriented computing as a new era of computing. Okay, I'll tell you why I'm saying it as a new era of computing. So before starting, I would always like start with an analogy, like the service oriented. What is service in the real life, like in our in our human lives? Okay. So these days, like we don't want to spend our time in doing chores, right? Like our own task, our own works. Like, but luckily we have all these all kinds of services. It's already exist. Okay. Like for example. Um, I don't want to spend my time in cooking. So what I can do, I can simply take the service of Swiggy or Zomato, and I can order the food. So either they will prepare the complete food, or they can, or even if I if I go some like apps like Swiggy, like they can also provide the food like raw food. Okay, and even I don't need to go to work by ride. Okay, if I simply use the Uber service, okay, then I can just they will take me to my workplace. Okay, so these are like services available in the real, our human life in the real world, right? So similarly, we have the services in the computer field as well. Okay, so for example, I want to do some transactions. Okay, I want to develop an e-commerce application, so in that we need to do some transactions. So when we want to do some transactions, I don't need to contact the banker for doing these transactions and everything. So what they will do, they will just provide a service, like they will we can either go for the PayPal service for doing our transactions, or Visa service, or this all these services are being provided. Okay, so even in the computer domain also we have the services. So in today's uh, webinar, so we are going to see like how to access those kind of services, and how this new computing has been changed. So previously, so that's what. Okay, so the agenda will just talk about the service oriented computing and service oriented architecture. So now currently, like if I see like 2 3 years before, like most people will start using like object oriented computing and so on. But now in the new era, so people are shifting from object oriented computing to service oriented computing. So why we are shifting from object-oriented computing to service-oriented computing, that we also will explain. And what is this services, web services, and what are the different kinds of web services, and everything we'll discuss in today's thing. Okay. Let's start with the service-oriented computing. What exactly the service-oriented computing? The service-oriented refers to the set of concept, principles, and methods that represent computing in service-oriented architecture for the development of the service software applications. Okay. So now, what is the service-oriented architecture? So the service-oriented architecture defines the way we have to develop the software components for the reusable and interoperable via the service interfaces. Okay, so now we understand that there is something called a service oriented computing, where we will only talk the two machines in terms of services. Okay, so how to implement this kind of service oriented computing? We don't have any direct technology to implement this service oriented computing. So in order to implement this service oriented computing, okay, we can there are many ways to implement this service oriented computing technology. So either through the web services, okay, or we can also implement the service oriented computing through microservices. Okay, web services, microservices, and any cloud services and so on. Okay, so first we'll understand why we have to move to the service oriented computing, and or like why the already companies has been moved from object oriented computing to service oriented computing. So here what we'll do is in object oriented computing we have the all tightly coupled classes where we have we'll run all like some monolithic kind of architecture where entire code will be running in the single system. Okay, and it is tightly coupled. So what will happen there when all things are packed in a single package? So for example, even the database is there in the single thing, and even the logic, business logic, and the user interface, if all things are combined in a single package, and if if we are providing, so what happened at that time? So the load, even if I want to access simple web page, the load will be on complete system, right? So but whereas in service oriented computing, what we'll do, we'll develop the applications by loosely coupled services. Like we'll have one services running in one system and the other service one running in the other system. So with this services can communicate with each other. Okay, with that the database service in one system and the business logic in one system, and like this. Or we can use the existing services also. Okay, so that the reliability is more. And moreover, not only that, okay, we can we can build this we can develop this application in a team environment where we don't need to we can separately like a MVC kind of architecture. We can develop like model and view and architecture by three different the developers and so on. And the code reusability is very high in the service oriented computing compared to the object oriented computing. So these are the basic differences of why companies are moving from object oriented computing to the service oriented computing, right? So now we'll see how the service oriented computing should be developed. Okay, and how the service oriented computing are being developed. So as I told, like there is no direct technology for implementing the service oriented computing. We can use the web services, microservices, and so on. Okay, so first we'll discuss about the web services. Okay, and then we'll discuss the later on the microservices. So again, the web service is, what is a web service? So web service is a network accessible interface to application functionality built using the standard internet technologies. And this in other words, the applications run over the network. Okay, because that's one service is running in one system. Like example, for the payment service, the payment service is running somewhere in the bank server. Okay, and our application, like if you develop this any e-commerce application like Amazon kind of thing, or the or like Athra.com kind of thing, or any kind of web application, e-commerce application when you're developing. So we will use this service, right? So we will use this service which is running in the bank server. So that is with the help of the internet protocols like HTTP, XML, and SMTP. Okay. So what exactly like web service? It's like abstraction will be provided, and there is no platform, like there is no platform dependent it is there. And how it is not platform dependent? Like if you take the any example, any real-time example. Okay, for example, if I'm taking as some book my show app or any app. So what will happen there? So we are taking the service of Visa or PayPal. Okay, Visa or PayPal, and now we have many payment services. We can take any of these payment services. We no need to develop a new payment services. So now what is happening? So book my show, when we book the ticket, it is direct into this PayPal services or Visa services and so on, so that the payment will be taken care by this one. And the book my show application was developed in some Android, or if it is in the if it is in the in the iPhone, it will be the iOS or Objective C. And the PayPal services was developed in like it's like PHP or the .NET or Python, any language, but still we are able to still communicate it. So why do we need these web services? So why do we need these web services? So like these days, all applications are developed in different languages. So and this should be supported with. We don't need to develop the already existing services from scratch. So what we need to do, we need to make use of those services so that it should be interoperable. it should be system dependent, it should be platform dependent, it should be language dependent. So this problem will be solved using the web services, and this and solutions for the business will be developed the flexibility and agility in application to application communication over the internet. Okay, and it enables the collaboration between the existing applications that are models as service and aggregated as the web services. So what is the main purpose of web services? It will try to solve the interoperability issue between the applications. Okay, previously when there is no web services, if I want to communicate with the application which is developed in one language and the application developed in another language, if I want to communicate, it was too hard, right? But this problem has been solved with the help of the web services. So what kind of web service? We have two different types of web services. One is SOAP web service and RESTful web service. Okay, the SOAP is a bit old. Okay, RESTful is the latest one. So people now for microservices implementation and everything, people are using for the RESTful web services because of the easiness and everything. Okay, but let's study what is the SOAP web service and what is the RESTful web service. So SOAP means simple object access protocol. Okay, SOAP is a simple object access protocol, whereas REST means representational state transfer web services. Okay, so in the SOAP, like it is a transport independent message protocol, because when the two application wants to communicate, okay, two different applications which is developed into different languages or different is installed or deployed into different systems, if they want to communicate, okay, this should be able to communicate through SOAP. So how they can able to communicate? Using the common language, right? If I wants to talk with the Chinese guy or some guy, I need to, he don't know my language and I don't know his language, so we need to have a common language so that we can able to understand each other conversations, right? In the similar way, when the two applications wants to communicate which is developed in two different languages, so we have the common language to communicate. What is the common language which can be communicated with? The XML is the common language. So SOAP is developed based like XML concept. Thus we have this based on the transferring of XML data as SOAP messages. Okay, each message has something which is known as XML document. We'll see in detail about this SOAP in the next slides. And the REST is a lightweight, maintainable, and scalable service that is built on the REST architecture. So the SOAP is a protocol, and this is an architecture. So which exposes the API for the applications, so that the other applications can able to communicate with securely, uniformly, and with stateless manner. Okay. So at this point, like, you need to understand what is the web service and what is a web application. Okay. So web application, like when I request for anything in the web, okay, what is the return? We'll get the return in the web page like HTML. Okay. But web services, if I return some URI, like if I request for any resource, okay, then I will get the resource. It's not like I will get the HTML. So that's the difference here. Okay, it's not like the content which is always for in the HTML format. The web application, when I request anything, it will always return in the form of HTML. But whereas in web service, okay, we can get the input information from the text format or JSON format or Excel format and so on. Okay. So why this is required? Like if I take an example of the Alexa, the Alexa one, Amazon Alexa. So if I ask for what is the weather today, right? So what it need to do? Does it have any web the weather application installed in it? No, right? So what it will do? It will try to communicate with the weather web service. Okay. So when it communicate with the weather web service, if it is, so what it will do? It will give a plain text. Okay, this is the weather information. Then what Alexa will do? Alexa will read out it. But if I have the web application, okay, if it is contacting the web application, okay, then it will give for a simple information. So it will give a lot of text document. The HTML document consists of head, body, CSS, and all other information. So the Alexa will be confused, like which is the exact information, which is the things. So this need to, the Alexa needs to remove all the tags, okay, all the CSS, all the HTML tags and everything. I need to find the plain text, and then it should be read if it is a simple web application, right? So this will be taking more time, and this will be taking more time, and this will be some time it will give the, it will read even the HTML tags and so on. But if I, the same thing if I use the web service, so when I request for the weather information, so what it will do, it will return in the simple plain text or XML document or JSON document, whatever the format we require, it will be giving, so that it is the, you know, application, the client, it will read out the things. Okay. So yeah, so now we'll see the architecture of the SOAP. So for the architecture of the web service, so we have the service requester, okay, service provider and service broker. Am I audible?
Yes, sir,
Yes.
you're audible.
Okay. Yeah. Thank you. So actually, there is the
Yes, yes,
power
sir, you can
connection.
see the lights are off from your
Yeah.
side.
Yeah. Yeah. So we have the service provider, service requester, and service provider. Okay, the service provider, what is the responsibility of service provider? The service provider responsibility is like to develop a service. Okay, it's simple, developing a service is not enough. So what the service provider should do, it should develop the web service, and it should be registered somewhere, so that the client service requester can request the service broker that whether this service is available, and if it is available, the service broker will return this information. Okay, so the service provider will register the web service. After developing the web service, it will register the web service. Okay, and the service requester will request for this whether this web service is available or not. So if the web service is available, it provides the information about the web service, like what information it will be provided, in which system this web service is running, what is the operations that is providing, what is the services that is providing. All the information will be given back to the service requester, and with that information the service requester will invoke the services, and he will get the service. Okay, so this is the complete architecture of the SOAP. Okay, so provider, that, as I said, the provider creates a web service and makes it available to the client application who wants to use it. And the requester, a requester is nothing but a client application that needs to be contact a web service. The client application can be any language, and can be use that service. And the broker, service registry or UDDI, all are same. So the broker responsibility is for, you know, storing that information, and whenever the requester is accessing requesting for the service, so I should able to broker should able to provide that information to the requester. So what are the operations of web service? We have the operations like publish, find, and bind. So who will publish it? So service provider will publish the web service into a service registry, and service requester will find the request for the find the web service, and once it has been given, okay, and the service registry will bind the web services uh, to the service provider. And so here we need to understand the couple of things. Okay, so first the service provider will register the web service, right? So register web service is, it will not register complete web service, it will only register the information about the web service. So in the form of the XML. Okay, for example, so I will explain this concept in a simple analogy. Okay, so for example, if I take a Swiggy, okay, if I take a Swiggy application or Zomato application, so the owner, the hotel owner or hotel, the restaurants and hotel owner, they, what they will do, they will develop the they will prepare the food, right? They will prepare the food, and what they will do, so the menu and the items and all the description will be published. Okay, the published in the Swiggy or Zomato, right? So that is the publishing. So whether they are they're providing entire food in the Swiggy, no, right? They are not keeping entire food in the Swiggy. So what they're doing, they're just giving the information the what is the cost of this food and item, and what the like what are the discounts, and all this information has been just kept in the Swiggy. That is the service broker. Here Swiggy is the service broker, and we like clients, what we'll do, we'll just take this information, right? We'll try to find like whether this is available. For example, but any item like biryani is available or not, something like that. Any sweets are available. So it will just search. We'll just try to find that whether this food available in Swiggy or not. In the similar way, the service requester will find whether this service is available or not. If that is available, the service broker will reply that okay, this is available and this is the information. Okay. So and this Swiggy also will do the okay, this is available, this is information. But the difference between that Swiggy and this architecture is there the Swiggy itself will place the order, but here they will service broker will not place will not directly link with the service provider. Okay, so what it will do, it will just give all the information like this is the service, this is the the service is running in this particular IP address, and with these are the operations and so on. So all this information has been given to the service requester, and now service requester using the SOAP protocol, okay, the SOAP messages, it will able to establish communication with the service provider, and it will able to communicate it. Okay, so here service provider will publish the services, that is information about the services, using a document called WSDL, okay, web service description language, and service requester and service provider will able to communicate the messages in the form of SOAP. Okay, now we'll see how this SOAP will looks like, SOAP messages will looks like, and how the WSDL will looks like, and how this UDDI and things will be looks like. The SOAP, okay, so the SOAP plays the major role of exchanging the information between the service provider and the service requester. So what it consists of? It consists of SOAP envelope, SOAP transport, SOAP encoding, and SOAP RPC conversion. So these are the XML tags. Okay, these are the XML tags, because only I told right, only the two, if they want to communicate with the two applications, it should have a common language. The XML is the common language. Based on the XML, this SOAP has been implemented. So this is the sample SOAP example. If I request for the conversion rate, okay, BRL to the Brazil rupee to the European. So this we have a SOAP envelope, SOAP header, and SOAP body, and this is the operation. The web service name is get currency, and these are the inputs, okay, and the body and envelope. So when we submit this request, we'll get this response. So what is the response? Get currency response, and the value is 5.8679, and this is the again. So everything will be communicated in SOAP. And WSDL, I told right, the service provider will publish the services, the information about the services. Okay, the information about the service. What is that information of services? In the form of web services description language, WSDL. So what it consists? It consists of like what is the message, okay, what is the port type, what is the binding. What does this mean is like this will provide like if I want to access, any web service, which IP address I have to connect to the server, or in which IP address this web service is running, on which port number that is running, okay, and what operation, with what operation I have to invoke the particular web service. So all this information will be stored in the WSDL. Okay, by seeing this information, the clients can able to develop the client application. Okay, so this is the simple WSDL for the currency conversion service. Okay, we have WSDL web service binding. Okay, so here we can see all the operations in the web service binding. We can see all the operations. So operation name is get exchange rate. So if I want to use this operation, so this is the name. Using this name, I should able to get this, invoke this service. Okay, and we have the convert and so on, and also we have the publish URL. So this is the location where this web service is running, okay, and the port and so on. So and UDDI is the service registry or service broker. Okay, so in this service, the responsibility of UDDI is to publish the web service, publish this WSDL, okay, store this WSDL, and whenever the service requester is requesting for the web service, it should find in that, it should able to publish the web service. Okay, and we have the publish URL. So this is the location where this web service is running, okay, and the port and so on. So and UDDI is the service registry or service broker. Okay, so in this service, the responsibility of UDDI is to publish the web service, publish this WSDL, and whenever the service requester is requesting for the web service, it should find in that registry. Okay, that is the responsibility of the UDDI. So this registry can be globally present or it can be privately present. So it doesn't matter wherever it is there. So if it is locally present, it is limited to the local. If it is publicly present, then it is available to all. So how can we implement it? Okay, so now we discussed about the concepts, okay, the architecture and the concepts. So how can we implement it? So it's simple. First we need to like develop the web application, and we need to web service. We need to develop the web service, and that web service description we need to deploy or register in the registry. Okay, and then service provider will the service provider registers a WSDL based service description with a service broker with a UDDI registry. And what is the UDDI registry will do? The UDDI registry stores the service description as binding templates as URLs to WSDLs. And this is the important. Okay, from here it is important. So we have JAX WS and JAX WS. Uh, this JAX WS. Okay, we have this CXF. Okay, and Oracle IBM. So using this technologies only. So whatever we have the concepts of SOAP architecture and JAX WS, this is only the standards and specifications. Okay, but if I want to implement it, okay, if I want to implement it, I have to either use JAX WS, either we have to use Apache CXF for Oracle WebLogic implementation and IBM's PA implementation. So I have to use one of these technologies to implement the web service in the SOAP. Okay, this is similar to like in Java, we have a list. A list is only specification, but the implementation of list is array list, right? In the map also same. It's like map, and this is just a concept map, and but actual implementation is the hash map. In the similarly, the SOAP and this the SOAP architecture is just an specification. So to implement this, so we have this technologies like JAX WS CXF and the Oracle WebLogic implementation, and we have to use one of these to implement those things. Okay, so the next one is REST. So now the problem with the SOAP is everything looks good, but the communication is only happening with XML to XML. And if I want to convert into some other format, again, after receiving the XML, I have to convert it, right? So exchanging of thing is only in XML. And the other thing is, it is only, at the synchronized. It only, the request and response kind of thing. It's only the synchronized. So to avoid these two limitations, okay, like, exchanging of XML, and the output is always in XML, and the other one is like synchronous. So the REST has been proposed. So what is the REST? Okay, so there is a protocol, and here it is an architecture. Okay, that is the main difference. So here in this architecture, what we'll do, we'll use this HTTP methods like get, put, delete, post. So using these methods, so we can invoke any service. And normally, like so here by default it has like all the serializations and everything has been proposed in the REST. Okay, so what we need to do, we need to just annotate some tags like at get, at produces, and so on. There are some tags. Using the tags we can able to implement the REST. But the concept behind this REST is, okay, instead of here, so simple SOAP, this is simple object access protocol. We are only accessing the objects, and how the objects has been transferred in the form of the SOAP messages, that is in the XML. Okay, so whereas here in the REST, so we can get in any format. If we request for the JSON, it will get in JSON format. Simple text, will get in text format. So whatever the format we require, if we request, it will be displayed. And the other simple thing is, it is using the HTTP methods. Okay, like get is used for specific representation of resources, and put is to create the create or update a resources with supplied representation, and delete is to delete the specified resource, and post is to submit the data to be processed by the identified resource. Okay, so here the state has been transferred, there the object has been accessed. Here that's why it is named as REST. So we have like the data elements like uniform interface like get, put, post, delete, so that because this HTTP protocols has been supported by all the companies, even the firewalls. Most of the companies will not restrict the HTTP, right? It will allow the HTTP, but they will they'll stop RPC and other things. So because most of them are allowing this HTTP, so this can be used in all the companies. And the resources oriented, simple, and like it's very simple. So this is the HTTP method: post, get, put, delete. The method is to create, retrieve, update, and delete. And as I said again, the rest is only specification. Okay, to implement it we require some implementations. Okay, we have Jersey. Okay, we can use the Jersey for implementing the REST APIs. Okay, or we can go for the REST easy. There is another implementation for JAX RS. Okay, for JAX RS is for the REST API. JAX WS, okay, is for the web service. And these are the two implementations for the JAX RS, Jersey and REST AC. So far everything is good. Okay, so far everything is good. We have SOAP and we have this REST. But what are the challenges of using these web services when we are trying to implement these web services? Okay, what we need to keep in the mind. So we need to keep this three things in the mind. First is distributed transactions and quality of service, and the security. So what is the distributed transactions? Okay, the distributed transaction means, so because one service is running in one system, another service is running in another system, and so on, right? And this system may be used some Python and Linux platform, and another system may use this PHP and Mac and the other system. So first, before actually implementing it, we have to check whether all this services been working properly or not, whether it is able to communicate with all the services or not. That we need to check. All the distributed transactions should be tested with the standard solutions. And the other important is quality of service. Okay, that is for the mission critical solution. What is mission critical solution? For example, okay, if I am not taking a decision in a specific time, okay, it may cause some damage. For example, if I have this the traffic signal, okay, if I have this traffic signal and I'm making this traffic signal as automated, okay, and some ambulance is coming from one direction, okay, and if this is not taking the proper action, like when it should able to detect this ambulance, and it should allow this ambulance to go in any direction, right? So if we have some delay, okay, if we have having some delay in detecting it, okay, then it may cause some damage, right? So this is called as mission critical solution. So because the web services are running remotely, okay, we need to test it before deploying. We need to test whether it is reliable or not, whether it is high availability is there or not, load balancing, failure, all these things, whether all the services has been providing or not, we need to see. Okay, and the final is security. Because it's HTTP based protocol, okay, we need to do the security, like authentication and authorization mechanism using the SSL. Okay, so this is the complete about the web services. Okay, and we have now microservices. Okay, with the help of REST API we are developing the microservices. The simple difference between the web services and microservices is, okay, the web service is like a component, component level. Each component can be provided as a web service, but in the microservices, each task can be provided as a service. Okay, that is the main difference between these web services and microservices. Okay, so that's it. If you have any questions, feel free to ask me.
Anyone has any question, please go ahead. So, sir, actually, I have one small doubt.
Yeah,
Actually,
please, please.
so this web services protocol, the frameworks you have explained, that is the REST architecture and the SOAP protocol. So whether these are two-layer implementations, like one server side and another client side implementation, or it is one layer, like?
Yeah, so it is like, if in the example of the web service and the PayPal or the Visa service, so only one layer. Okay, we are taking the help of the other web service which is already existing. But
in the
if
servers, in the server side, sir.
in the server side. So if we are developing our own web service, then we need to do it two ways,
Both
like
the layers,
two
yeah.
layers. Yeah.
So I just want to know that is there any load balancing scheme, like any scheduling scheme attached, because so many this web services, it is being accessed by so many users, right? So
Yes.
at a time
Yes.
many requests are coming. So is there any
Yes.
scheduling mechanism associated with these frameworks?
Yes. So this is a simple implementation. So as a developers, we need to create this scheduling and load balancing kind of thing. But the thing is, mainly it's like not a monolithic kind of architecture where entire thing is loaded in a single system. As it is distributed,
Yes, yes.
so the load will be bit less. And even though when the load is less also, so we can still able to replica, we still able to provide all kind of facilities.
Oh, okay, okay. So I guess no one else is having any questions. So we can now come to the conclusion. Okay, before concluding, let me extend our gratitude to our speaker as well as all the people associated with this webinar. Firstly, on behalf of our Computer Science and Engineering Department, I would like to thank Dr. Sudheer Kumar Battula sir for his this lovely session on such a trending topic. Actually, a couple of weeks ago, we had a discussion in this SOAWAL second, I think, or third, maybe second webinar on agile software development. Durga Prasad Mahapatra sir was there. So this is again another episode that can be added to that robust software development by implementing this service-oriented architecture platform into the software development architecture. Okay, so thank you, sir, for taking the time out for your busy schedule and enlightening us with your research expertise. I hope all our participants will be benefited from this discussion. Uh, Again, I would like to thank Professor Dr. Debahutri Mishra Madam, our HOD CSE department, Dr. Sarada Prasanapati sir, Dr. Divya Sundar Das sir, Dr. Bharat Jyotiranjan Sahu sir, and Dr. Madhuri Rao Madam for their valuable support and the continuous effort towards making this webinar a successful one. And thanks to all the faculty members, research scholars, UG and PG students who have joined us during this webinar. Thank you all and have a great weekend. I think, sir, we can conclude now.
Thank you very much, sir. So thank you for
Welcome, sir.
giving this opportunity and presenting this latest computing era.